Welcome back. Today we will discuss a particular type of problem on time and work. Time and work. Tank tap problem. Now what is this? Suppose there is a tank and one tap is fitted to fill up the tank. Now, if this tap fills up the tank totally in suppose X minute and another tap B separately fills the tank in Y minute. The problem is if these two taps are operated simultaneously, then what time it will take to fill up the tank? Okay? You can add more taps again, tap C. The problem is similar and the process is also similar. Let us take one example. Suppose a tank is filled up by tap A in 16 hours and by tap B in 20 hours. What time it will take to fill up the tank if the taps are operated simultaneously? Okay? To solve this type of problem, you have to find out the portion of work or the fraction of work done in unit time, that is 1 hour. For this tap A, it takes 16 hours to fill one part, that is total. So in 1 hour, obviously it will fill less, that is 1 by 16 part. Clear? For tap B, similarly, in 20 hours it fills one part and in 1 hour it fills 1 by 20 part. Now when these two taps are open together, then in 1 hour they will fill 1 by 16 part plus 1 by 20 part. So the LCM of 16 and 20, you can do it. This is 80. So 16, 5, 80, 24, 80. 9 by 80 part. So in 1 hour, it fills 9 by 80 part. Now, you can take this part in left side and solve the, find out the time. That is, if 9 by 80 part is filled up in 1 hour, then the total, that is one part, is filled up in 1 by 9 by 80 hour. So it is reverse 80 by 9 hour that is 8 whole 8 by 9 hours. This is your answer. So you can see that we have to go for what part of the tank is filled up in 1 hour, and then we are adding the different parts from tap A, from tap B, and if there is one tap C, you can also take that C part also. Then you are finding out what part is filled up together in 1 hour, and the time taken is just the reverse of that part. Now, another question for your own practice. Suppose two types of tap, type A, type B. In the earlier question we said tap A, tap B. Now I am saying type A tap and type B tap. Okay. Now this type A tap, it takes 26 minutes to fill a tank, and this type B tap takes 39 minutes to fill that same tank. Now the question is, if there is 3 number type A and 2 numbers type B tap, then what time it will take if all the taps are operated at the same time? So nothing to worry about. We will proceed in the same way as the previous one. For type A tap, it takes 26 minutes to fill one part. So 26 minutes for one part. In 1 minute, it will fill up 1 by 26 part. Okay. So type A type tap, there are 3 numbers. So if 3 number of taps operated together, then it will fill thrice the volume. So for 3 number of A type tap, it is 3 by 26 part in 1 minute. Clear? Similarly, for the second type, you can do it yourself. It takes 1 by 39 part in 1 minute and 2 number of taps. So it is 2 into this 2 by 39 part. Okay. So from type A tap, we are getting 3 by 26 part in 1 minute, and from type B tap, we are getting 2 by 39 part in 1 minute. So if they all are open together, what will happen? In 1 minute, it will fill 3 by 26 plus 2 by 39 part. So it is 78 LCM 6, 3, 9 and 2, 4. 13 by 78 part. So what time it will take to fill up the tank? You just seen, we have to reverse this part. 13 by 78 part in 1 minute. So one part 1 by 13 by 78, so it is 78 by 13 minute. Okay, clear? So the basic thing is same. For one tap we are calculating what part is filled up in 1 minute, and for the second tap what part is filled up in 1 minute. If number of taps are more than one, then we will multiply that part with that number, that part with that number, and then add. So this is the basic thing of these problems. Now one more type of problem can be there, that one tank is filled up by a tap and there is a hole. That is draining out the water. So you are pouring water from the tap, but that is some part of this is drained out through this hole. So you are adding, this is plus, and this is getting out, this is minus. The problem is same. Suppose if you take tap A fills the tank in 4 hours, and if the entirely filled tank is emptied in 6 hours through this hole, then what time it will take if the tap and the hole both are open? So the tap is pouring the water and the hole is just taking it out. So for this tap A, again 1 by 4 part in 1 hour, and the draining is 1 by 6 part in 1 hour. So what is the resultant after 1 hour? You have poured or filled 1 by 4 part and 1 by 6 part is drained out. So what is the resultant? What is left out? That is 1 by 4 part minus 1 by 6 part. Minus. This draining out is minus and pouring in is plus. So 1 by 4 minus 1 by 6 part. Okay. LCM is 12. 3 minus 2. 1 by 12 part. So now you can conclude that it will be filled in 1 by 1 by 12, that is 12 hours. So the tap could have filled the tank in 4 hours, but as the hole is there and it is draining out water at a rate of 6 hours for the tank, so it is taking 12 hours to fill the tank completely, even the drain is there or the hole is there. So this is the basic type of this particular problem. This comes under the category time and work, and we have shown here that if both 2 or 3 or multiple taps are working together, or there are taps working and holes also working to drain out the water, how can you solve or proceed with this problem? So this is all for today's class. We'll come with another important topic in the next class. Thank you.